Now I'm going to take a different tact, and we're going to rationalize binomial denominators. So for an expression with a binomial denominator that contains a radical, we have to multiply the numerator and denominator by the conjugate of the denominator. Recall that the product of a pair of conjugates is a difference of squares. So what is a conjugate? Well, if x plus y is one expression, the conjugate is simply x minus y. Or if the factor is x minus y, the conjugate to that is x plus y. Now, what's so special about multiplying conjugates? They create a difference of squares. And there we have it, a difference of squares. Now, it's not our first encounter with a difference of squares, and it won't be the last. So I did some multiplication if you are having a hard time following with this. And so in the red, I have a minus b. The conjugate to that is a plus b. And if I multiply a minus b to a plus b, I end up with a squared minus b squared, a difference of squares. Now, it doesn't matter the order of the factors, but here I have the root of x minus the root of y. So that is one factor. Multiply it by its conjugate, the root of x plus the root of y. And I carried out this multiplication. And what's interesting is that generally in a binomial, we have a binomial times a binomial creates 4 different terms, in which 4 simplify down to 3. But what happens in a difference of squares is we have 2 terms that cancel each other out. Plus root of x plus the root of xy minus the root of xy simply cancel out. When you add them together, they create 0. And the factor, the root of x squared simply is x. So long radical, there it is. And the subtract, the root of y squared just becomes y. So you end up with an expression with no radicals. And that's if you multiply by the conjugates. Now, if you want, you can pause the video and take the look at the last. I guess what I'm trying to say is when you multiply conjugates, it creates a difference of squares. It's a really effective way to get rid of radicals. Right. So here we have it. What I'm going to do is I am going to take the expression 5 times root 3 divided by 4 minus root 6. Now I'm going to multiply by the conjugate of the denominator. So it is going to be the same expression, except if there is a negative, here I have to make it a positive. And that is multiplying by the conjugate. So I have to multiply both top and bottom by the conjugate. Now what we may see is we can take the shortcut and be able to say, well, if I am multiplying a plus b with its conjugate a minus b, it creates a squared minus b squared, the difference of squares. In other words, my denominator will be 4 squared minus the root of 6 squared. The numerator is a monomial times a binomial. So I'm going to have to take 5 root 3. I'm going to multiply it by 4, and that's 20 root 3. And then I'm going to have to take 5 root 3. I'm going to have to multiply it by root 6. So that creates, 5 root 18. I'm going to take a look towards, just going to clean some stuff up. So I'm going to leave this first term of my numerator the same. The second term of my numerator, just for now, I recognize that 9 is a perfect square that is a factor of 18. So I'm just going to rewrite this, possibly, maybe things are going to simplify later, as 5 times 3 root 2. Divide this by 16 minus 6. So this ends up being 20 root 3 plus 15 root 2, all of that divided by 10. Now that went really quick. So again, in step 1, I need to multiply by the conjugate. Step 2, when we multiply conjugates, they create a difference of squares. You can see it here. At the top, I had to multiply using binomial multiplication. And now I'm just going to simplify in step 3. Step 3 was pretty fun, but really all I did was I simplified 5 root 18, and root 18, by the way, can be simplified in 9 root 2, and that's why it's 3 root 2. That's why that came into play. And then the bottom is 16 minus 6, and what I get is I'm going to divide both top and bottom by 5, for I see that the coefficients all have 5 for a factor. If I do that, that is 4 root 3 plus 3 root 2, all of that divided by 2. That was fun. Let's go into a different example. Now, I'm going to move all the way to this example. Now, the numerator is a binomial, and the denominator is a binomial. So I'm going to multiply the denominator by the conjugate. I'm going to start off with the conjugate and be like, oh, I don't like that denominator, and I'm just going to multiply it by the conjugate, and there we have it. So I'm going to multiply the denominator by the conjugate. So if I want to maintain the value of this expression, I need to also multiply the numerator by the conjugate. There we have it. So I'm just going to maybe put brackets around the top, just so that it's easier to see. Now I'm going to multiply numerator with numerator, denominator with denominator. Now, I think there's going to be some work involved here. So shall I begin in numerator to numerator? I'm going to do 2 green multiplications. So root 3 times root 6. Now I'm going to write root 3 times root 6. And I'm going to do that second green multiplication. And I'm just going to say negative 4 times root 3 times root 3. So there's part of my numerator. Now remember, the numerator is a binomial times a binomial. Now I have to take this next term. I'm going to multiply 2 by root 6. So I'm just going to say positive 2 root 6. And the second one, I'm going to go root 2 times negative 4 root 3. So I end up with negative 4 root 2 times root 3. Now I'm hopefully going to clean this up a little bit and things simplify. Now I could also expand my bottom exactly how I did it the numerator, but what you're going to see is a difference of squares. So my first term is root 6, so that's going to be root 6 squared. My next term is 4 root 3 squared. Since I'm multiplying the conjugates, it's going to create a difference of squares. So it's seriously taking up a lot of real estate here. I'll work on this numerator if you don't mind. Now, I'm going to take a look at this, and perhaps I'm going to take a little bit of a longer road. So I'm going to say root 3, and root 6 I'm going to write as 3 times 2. Now, this next term, simple, not simple, but step by step, negative 4 times root 3 times root 3 is actually negative 12. Root 3 times root 3 is 3, times negative 4 is 12. Now, this next term, the blue term I'm going to call this, if you will. Now, I see root 2, and then I ask myself, does maybe root 6 have a factor of 2? And it does. So I'm going to add this blue term, and that is root 2, and root 6 can be expressed as root 2 times root 3. And perhaps this pink term right here, I'm going to think about it. Well, that is not very nice, actually. Perhaps I'm just going to write this down as it is, and there may be an opportunity to simplify later. So that's my numerator. So I need to clean up my numerator, obviously, and hopefully I'll get the chance. Now, I'm going to take a look at the denominator, and I'm going to start off with this term here. Root 6 squared simply is 6 minus 4 root 3 squared is 4 squared times root 3 squared. Now, definitely running out of space, but I'm going to move this up. I'm going to rewrite it. Root 3 times root 3 times 2 can be written as 3 root 2. I'm going to call this the yellow term. Minus 12 is definitely up there. I don't know what to do with that yet. I'm going to simplify this blue term, and root 2 times root 2 times root 3 is better off written as positive 2 root 3. Last but not least, this pink, the last term. Can't be simplified, so I'll just write minus 4 root 6. Now I'm going to take care of the denominator, and I think the denominator is going to be 6 minus, well, 16. 6 minus 4 squared is 16 times 3. So this is 3 root 2 minus 12 plus 2 root 3 minus 4 root 6 all over. And now if I just simply do this calculation in my expression, negative 6 times 16 times 3, I believe 16 times 3 is 48. So it's 6 minus 48, and that leaves me with negative 42. Unfortunately, you can't have a negative in the denominator, so what we're going to do is we're just going to multiply both top and bottom by negative 1. And when you multiply a polynomial by negative 1, it just simply changes all the signs. There we have it. There is our rationalized denominator.